Welcome to Astronomy Daily, your regular dose of the latest and greatest from across the cosmos.
We're your hosts, Avery and Anna, and we've got some truly fascinating stories from the world of space and astronomy for you today.
We'll be starting by remembering a true legend of space exploration, astronaut James Lovell, whose incredible life and contributions left an indelible mark on humanity's journey to the stars. Then we'll shift our gaze to the night sky, discussing the upcoming Perseid Meteor Shower and whether the bright moon might put a damper on this year's viewing party. But don't worry, we'll have some tips for you. After that, we're off to explore a groundbreaking discovery by the Hubble Space Telescope, which has revealed evidence of a rare white dwarf collision, shedding new light on stellar evolution.
And finally, we'll launch into a truly ambitious concept, the potential for space travel to a nearby black hole within the next century, exploring the technology and the scientific implications of such a monumental journey.
So, get ready for an exciting tour of the universe. We begin our show today with some somber news from the world of space exploration. We're reflecting on the remarkable life of astronaut James Lovell, who sadly passed away recently at the age of 97. Lovell was a true icon, a member of humanity's first trip to the moon, and famously, the commander of NASA's challenging Apollo 13 mission.
That's right, Anna. NASA announced his passing, and acting administrator Sean Duffy released a statement saying, NASA sends its condolences to the family of Captain Jim Lovell, whose life and work inspired millions of people across the decades. Jim's character and steadfast courage helped our nation reach the moon and turned a potential tragedy into a success from which we learned an enormous amount. We mourn his passing even as we celebrate his achievements. It really speaks volumes about the man he was.
Absolutely. He was a 4-time Gemini and Apollo astronaut, but he's perhaps most famously known for his portrayal in the 1995 feature film Apollo 13. Tom Hanks played him, and Lovell himself had a great sense of humor about it, often joking at public appearances, "I know today when I came out, many of you were expecting Tom Hanks, but you're going to have to settle for little old me."
Such a humble man. His career was truly groundbreaking. He was selected with NASA's second group of astronauts in 1962 and first launched aboard Gemini 7 in December 1965. This was a pivotal mission as it was the first to include a rendezvous with another crewed spacecraft, Gemini 6, and he and Commander Borman spent 2 weeks in Earth orbit, setting a U.S. record for the longest spaceflight at the time, all in preparation for the later Apollo missions.
And he was a key figure in demonstrating the skills needed for lunar missions. He commanded Gemini 12, the program's final flight, where his crewmate, Buzz Aldrin, conducted the first truly successful spacewalks, showing that astronauts could effectively work outside a spacecraft. This was a huge step forward for the program.
Indeed. Then came his first trip to the moon as part of Apollo 8 in December 1968. This mission was revolutionary, marking the first time humans had flown to another celestial body. Lovell, Borman, and William Bill Anders were the first to see the far side of the moon with their own eyes and captured the iconic Earthrise photographs, which many credit with inspiring the environmental movement. Lovell himself said, "You had to pinch yourself. Hey, we're really going to the moon. This is it." It truly was a high point, as Lovell himself later reflected. That mission brought a much-needed uplift to the American people during the turbulent year, with a telegram sent to the crew stating, "You saved 1968." But of course, the mission that cemented his legend was Apollo 13 in April 1970. What was intended to be NASA's third moon landing quickly turned into a fight for survival after an explosion tore through the spacecraft's service module. That's when his famous line, "Houston, we've had a problem here," came into play. He saw gas escaping from the spacecraft and oxygen gauges dropping to zero. It was a dire situation, but his calm leadership, along with crewmates Fred Hayes and Jack Swigert, guided them through incredible challenges to a safe splashdown. It was a testament to his courage and ingenuity, turning a potential tragedy into an incredible story of human perseverance.
He was already a record breaker, even before Apollo 13. being the first person to launch into space 4 times. After his active flight career, Lovell continued to contribute, serving as Deputy Director of Science and Applications at what's now Johnson Space Center, before retiring from NASA and the Navy. He then moved into the business world, holding executive roles and serving on various boards.
And his contributions were recognized with numerous accolades, including the Congressional Space Medal of Honor and the Presidential Medal of Freedom. He was inducted into the International Space Hall of Fame, the U.S. Astronaut Hall of Fame, and the National Aviation Hall of Fame. A crater on the far side of the moon was even named for him in 1970.
His legacy extends beyond his professional achievements. His family released a statement saying they were enormously proud of his amazing life and career accomplishments, highlighted by his legendary leadership in pioneering human spaceflight. But to all of us, he was dad, granddad, and the leader of our family. Most importantly, he was our hero. We will miss his unshakable optimism, his sense of humor, and the way he made each of us feel we could do the impossible. He was truly one of a kind.
What a beautiful tribute. With James Lovell's passing, only 5 of the 24 people who flew to the moon during the Apollo program remain living. His contributions to space exploration and his unwavering spirit will undoubtedly continue to inspire generations to come. He truly embodied the adventurous and resilient spirit of human spaceflight.
From a somber reflection, we now turn our gaze to a more regular, yet still exciting, celestial event, the annual Perseid Meteor Shower. August is often dubbed Meteor Month for observers in the Northern Hemisphere, largely thanks to this display.
That's right, Anna. It's beloved by everyone from serious meteor enthusiasts to casual summer campers. However, for 2025, skywatchers need to be aware of a significant obstacle: the moon.
Unfortunately, this year, the moon will turn full on August 9th and will be in a very bright waning gibbous phase a few nights later, right when the Perseid peak is predicted to occur. That's for the overnight hours of Monday, August 11th, into the pre-dawn hours of Tuesday, August 12th. A waning gibbous is just about the worst moon phase for meteor observing.
It truly is. The moon will be 89% illuminated and will be flooding the sky with light through most of that key night. This will definitely hamper any serious attempts to observe the meteors. It's a bit of a redux of 1968 when the moon was in the same phase during the Perseid peak. Back then, a meteor watch in Central Park only saw about 1 meteor every minute or 8, when typically you'd expect 1 every minute or 2.
So quantity over quality then? Because moonlight only hides the fainter meteors. Many Perseids are known to be fast, bright, and often leave persistent trains. These brighter, streaky Perseids can definitely burn right through a moonlit sky.
Exactly. As Guy Ottewell notes in his Astronomical Calendar 2025, Perseid meteors are swift, many are bright, white, yellow, green, red, orange, leave spectacular, long-lasting trains, and end in flares. And occasionally, you get an outstandingly bright Perseid fireball that blazes forth, impressive enough to attract attention even with bright moonlight. So if you're willing to sacrifice the sheer number of meteors, you might still catch some truly spectacular ones.
The best time to watch, as always, is from 11 p.m. or midnight straight on until the first light of dawn. The meteors can appear anywhere in the sky, so just make sure you're watching in a direction where the moon isn't directly in your eyes.
It's definitely not the ideal year, as a single observer in the absence of moonlight might see 45 to 90 meteors per hour. We won't come close to that in 2025. But for those already thinking ahead, 2026 promises a much better show, with the peak night coinciding with a new moon and even a solar eclipse. So while this year is challenging, next year will be a different story. In the meantime, keep an eye out for a few celestial streakers, and don't forget the eye-catching conjunction of Jupiter and Venus low in the east-northeast sky a few hours before sunrise. It's a nice consolation prize for the moonlit Perseids of 2025.
From looking at our own skies, let's now pivot to a truly fascinating discovery made possible by the venerable Hubble Space Telescope. It has uncovered compelling evidence of a rare white dwarf merger, shedding new light on stellar evolution and the ultimate fates of binary stars.
This is a significant finding. Scientists at the University of Warwick detected carbon in the ultramassive white dwarf known as WD 0525 plus 526, which is located about 130 light-years away. In optical light, it looks like an ordinary hydrogen-rich white dwarf, but Hubble's ultraviolet spectra revealed something much more unique.
That faint carbon trace in its atmosphere is the telltale sign that this object is the product of a rare white dwarf merger, rather than just a single star's evolution. What's even more remarkable is that the detected carbon is 4 to 5 orders of magnitude lower than in previously known merger remnants, making this the earliest stage example of such a merger found so far.
It really highlights the power of ultraviolet observation. Normally, ultramassive white dwarfs hide their carbon beneath thick hydrogen and helium envelopes. But in WD 0525 plus 526, these layers are 10 billion times thinner. This thinning likely resulted from two stars merging and burning off their outer layers during the cosmic collision, leaving behind a stripped remnant with a nearly pure hydrogen atmosphere, yet with carbon still leaking through.
And the mechanism behind this carbon leakage is also quite intriguing. At nearly 4 times the sun's surface temperature, WD 0525 plus 526 is too hot for typical convection to bring up carbon. Instead, the team identified semi-convection, a subtle mixing process never before seen in white dwarfs that allows a modest amount of carbon to drift upward. This opens a new chapter in stellar physics.
The discovery challenges previous assumptions that hydrogen-rich white dwarfs lack carbon. It implies that low-level carbon pollution might be hidden beneath thin atmospheres in many ultramassive white dwarfs, only detectable with sensitive ultraviolet data.
This research deepens our understanding of cooling delays in what's called the Q branch of the Gaia-Hertzsprung-Russell diagram, which is linked to core crystallization. It also refines binary merger rates and helps us better identify potential progenitors of thermonuclear supernova. WD 0525 plus 526 acts as a benchmark for models of stellar mergers and white dwarf evolution.
It's incredible that Hubble, even at 35 years old, is still the only telescope capable of making such observations. The researchers stressed the vital importance of planning for a new ultraviolet observatory to continue this work and survey more ultramassive white dwarfs across the galaxy, which could reveal a whole hidden population of these rare merger remnants.
From uncovering hidden stellar secrets with Hubble, let's now set our sights on an even more ambitious concept: the idea of interstellar travel to a black hole. It sounds like something out of science fiction, but a new concept by astrophysicist Cosimo Bambi of Fudan University suggests a tiny laser-propelled probe could actually make this trip within a human lifetime.
That's absolutely mind-blowing. This vision, published in iScience, outlines how gram-scale nanocrafts could journey to a nearby black hole and directly test the depths of gravitational physics. The first challenge, of course, is finding a hidden black hole close enough.
Exactly. Known black holes like Gaia BH1 are over 1,500 light-years away, but Bambi estimates there might be one within 20 to 25 light-years based on stellar and white dwarf densities in our galactic region. Detecting one would require new techniques, such as microlensing or gravitational wave events, which could pick up the pull of an otherwise invisible object. Given rapid advances in these methods, Bambi argues we could locate a suitable target within 10 years.
That's a much shorter timeline for finding one than I would have thought. The core of this incredible mission lies in those nanocrafts. They'd be space probes weighing just a few grams, essentially a silicon chip-like wafer with a reflective light sail made from advanced metamaterials. A powerful laser array on Earth would push the sail, accelerating the craft to speeds approaching a third of the speed of light.
And at that astonishing speed, a black hole 20 to 25 light-years away could be reached in about 60 to 75 years. Once the data is gathered, the signals would take another 20 to 25 years to return, making the mission's full timeline around 80 to 100 years, potentially even shorter if higher speeds are achieved.
This isn't just about the journey. It's about the extraordinary experiments they could conduct near a black hole's extreme gravity. For instance, if 2 or more nanocrafts were used, one could orbit closer while another observes. The inner craft would beam a steady electromagnetic signal back to its partner. According to general relativity, the timing of that signal should match predictions of the Kerr metric, which describes spacetime around a rotating black hole. Any deviations could reveal new gravitational physics.
Another fascinating test involves approaching or even crossing an event horizon. If a nanocraft falls into a true black hole, its signal should become increasingly redshifted until it vanishes from view. But if the object is a fuzzball with no horizon, the signal might disappear suddenly. Only a direct mission could truly reveal the truth. They could even test if fundamental constants like the fine structure constant change under intense gravity.
Despite the incredible scientific payoff, there are major hurdles. The laser infrastructure alone would cost an estimated 1 trillion euros today, though Bambi expects costs to drop significantly over the next 2 to 3 decades. Nanocraft technology, including durable light sails and miniaturized instruments, still needs development, and communication across light years, navigation, and target precision are daunting.
Yet, as Bambi points out, breakthroughs once deemed impossible, like detecting gravitational waves or imaging black hole shadows, are now realities. His goal is to spark a conversation that could launch a century-long project, potentially opening a direct window into gravity's most extreme realm.
It's truly inspiring to think that future generations might begin building and planning for such a mission, while today's scientists are laying the groundwork. This interstellar ambition could transform astrophysics, allowing direct measurements of space-time in extreme gravity that either reaffirm or challenge Einstein's theory.
Well, that brings us to the end of another fascinating episode of Astronomy Daily. Thank you so much for joining us today.
It's been quite a journey through the cosmos, hasn't it? We remembered the incredible legacy of astronaut James Lovell, we discussed the challenging Perseid Meteor Shower this year, and explored Hubble's amazing discovery of a rare white dwarf collision.
And of course, we dared to dream about the possibility of sending nanocrafts to a black hole within the next century. There's always so much happening in the universe.
Indeed, there is. We hope you enjoyed diving into these stories with us, and please visit our website at astronomydaily.io for more news and to listen to our back episodes.
Join us next time for more celestial insights and the latest news from beyond our world. Until then, keep looking up.